Hi everyone, welcome to the Simple Spark where science lights up simply. If you are a student aiming to understand complex concept in the easiest way possible, you are in the right place. Today we are diving into the fascinating world of light, reflection and refraction straight from CBSE grade 10 science book. Let's get started. Let's start with a simple question. What is light? Light is a form of energy that allows us to see the world around us. Without light, everything would appear dark, even colorful things wouldn't be visible. Now, how does light travel? When it moves through the same medium like air or vacuum, light travels in straight lines. This behavior of light moving in straight lines is called rectilinear propagation. That's just a fancy way of saying that light does not bend or curve on its own while traveling in one medium. You can see the images, that is a glowing bulb or candle, the sunlight. So remember, light is energy. It helps us see and it moves in a straight line through the same medium. Now that we know what light is, let's talk about the sources where light actually comes from. There are two types of object when it comes to light: luminous objects. These objects produces their own light, means luminous objects are the objects that produces their own light. For example, the sun, the stars, the electric bulb, or even a burning candle, all these give off light by themselves. That's why we can see them glowing even in complete darkness. Next one is non-luminous objects. These objects do not produce any light on their own. We can see them only when light from another source reflects off them. Think about the moon. It looks bright in the night sky, but it does not make its own light. It just reflects sun's light. Other examples are table, book, or even us humans. So, to sum up, luminous objects glow by themselves, and non luminous objects need light from elsewhere to be seen. Let's talk about an important property of the light, that is rectilinear propagation of light. This simply means that light travels in a straight line when it moves through the same medium like air or vacuum. For example, if you switch on a flashlight in a dark room, you will notice the beam goes straight from the flashlight to the wall. It doesn't bend or curve. That's rectilinear propagation in action. You can see in this image a person watching the flame through the screen. But in the second step, if he move one of the screen, so he is not able to see the flame of the candle, so that the light always travel in a straight line. And this property, that is rectilinear propagation of the light, helps us understand how shadows forms and how pinhole cameras work. First, let us see the formation of the shadows. When light travels in a straight line and is blocked by an opaque object, a shadow is formed behind it. If light could bend around objects, we wouldn't see sharp shadows. You can see here a light source and one shape. When light falls on it, what happens? This shape blocks the light so that its image is formed on the screen. It is in a dark color. For shadow to form, what are the conditions? It requires the light source, opaque object and screen. And shadows are always dark and have the same shape as the object. Size and sharpness of the shadows depends upon the distance between the object, light source and screen. Shadows are always dark and take the same shape as the object blocking the light, but shadows can change the size and sharpness depending on how far the object is from the light source and the screen. Shadows have the two parts. So one is umbra and penumbra. The darkest part where no light reaches is umbra. A lighter, partially little area around the umbra is called penumbra. You can see here umbra and penumbra. Now let's explore a cool device called pinhole camera, one of the simplest way to form images without using a lens. A pinhole camera is basically a closed box with a tiny hole called the pinhole on one side. You can see the image. The opposite side of the box acts as a screen where the image appears. So below the image is there, you can see a small hole, that is pinhole, and the screen on which the image is formed. This camera works based on the principle of rectilinear propagation of the light, which means light travels in a straight line. Here how it works. Light rays from an object pass through the tiny pinhole. Because light travels in a straight rays from the top of the object reaches the bottom of the screen, and the rays from the bottom of the object reaches the top of the screen. That's why the image formed is inverted. It appears upside down compared to the object. The image formed by a pinhole camera is real, which means it can be projected on the screen, and the real image is always the inverted image and it is projected on the screen. So the images formed by the pinhole camera are real, inverted and smaller than the object. Early cameras and some photographic devices worked on this simple principle, and pinhole cameras are a greatest way to demonstrate the straight line travel of light. So now let's see how light interacts with matter, the things around us. So when light meets any material, several things can happen, like absorption, emission, transmission, reflection Refraction. You can see the behavior of the light when it interact with the matter. So absorption. Matter can absorb light, which means it makes in the light energy. For example, a black surface absorbs most light, which is why it feels warm in the sun. Next is emission. Matter can emit light, meaning it gives off light, like a glowing bulb or firefly that produces its own light. Next is transmission. Some material transmit light, allowing it to pass through them. Think of clear glass or clear water. You can see through them because they transmit light. Next is reflection. So light can bounce off a surface. That's how mirror work. They reflect light to form images. Next is refraction. When light passes from one medium to another, like air to water, it changes speed and direction. The bending of the light is called refraction. So the different materials interact with different colors of light in different ways, which is why we see colors and why objects look the way they do. So light and matter are constantly interacting, absorbing, emitting, transmitting, reflecting, or bending light, which creates the beautiful world we see. So, next we study reflection of the light. Let's learn about reflection of light. We know that reflection is when light bounces back after hitting a smooth surface like a mirror. Imagine shining a flashlight at a mirror. The light doesn't just stop, it bounces back. This is how we see ourselves in mirrors. Reflection helps us in many ways, from looking in mirrors to using shiny surfaces for signaling. So, the below images shows the reflection of the light. So, these reflections happen in two ways: regular reflection and diffuse reflection. The regular reflection occurs when the light reflects off a smooth surface like a plane mirror. The reflected rays are all parallel, so we get the clear and sharp image. The regular reflection here, the parallel lines strike onto the plane surfaces like a mirror, and it bounces back with the same parallel lines. So since it has a smooth surface, the reflection is a regular type, so it is called as the regular reflection. Here the incident rays are parallel and the reflected rays also parallel. And the next one is diffuse reflection. This happens when light hits rough surfaces like a wall or paper. Here the surface is not smooth. Here it has the rough surfaces. The reflected rays scatter in different direction, so the image is not clear or sharp. Here the reflection takes place, but what about the images formed? That is not a clear image because the surface is not smooth. So in the regular reflection, it has the reflection from the smooth surfaces and it gives clear images. Whereas diffuse reflection, the reflection occurs from the rough surfaces and image formed is not clear. Next is the laws of reflection of the light. So, laws of reflection that apply to all reflecting surfaces, whether it is a flat mirror or a curved one. So, these are the very important laws. The first law is the angle of incidence is equal to the angle of reflection. This means the angle at which light hits the surface, that is angle of incidence, is exactly the same as the angle at which it bounces off, that is angle of reflection. So we can write it as angle I is equal to angle R. So from the figure we can see that PQ is the mirror and AO is the incident ray. So the AO is the incident ray, that means it is incident onto the mirror. So the light ray which hits the surface is called as incident ray, and the bouncing back of the ray after reflection is called as reflected ray. So the incident ray is AO and the reflected ray is OB. So the angle made by incident ray and the normal is angle of incidence, and the angle made by the reflected ray and normal is angle of reflection. So according to this law, these both angles are equal. So the angle of incidence is equal to the angle of reflection. So the incident ray means the ray that hits the surface, and reflected ray means the ray that bounces back, and the normal line means it is the imaginary line that is perpendicular to the surface. So the point of incidence is nothing but O, where the ray strikes the surface. Angle of incidence is the angle between the incident ray and normal, and angle of reflection is the angle between the reflected ray and normal. So the angle of incidence is equal to angle of reflection. The second law is the incident ray, the reflected ray, and the normal to the surface at the point of incidence all lie in the same plane. This just means they are all in one flat surface, making it easier to understand and predict reflection. These laws help us understand and predict how light behaves when it bounces off any surface. Next is image formation by plane mirror. Let's learn how images are formed by a plane mirror. It's a shiny surface that reflects light. When you stand in front of a plane mirror, light rays from our body hit the mirror and reflect back to our eyes. So our brain traces these reflected rays backward in a straight line, creating an image behind the mirror. This image appeared to be the same distance behind the mirror as you are in front of it. So the image formed by the plane mirror has many properties, like it's a virtual, meaning it cannot be captured on a screen, and it is erect, that means it appears upright, that is a straight image. The size of the image is same as that of the object. So the image is straight, and also the size will be same as that of the object. The distance of the object from the mirror is equal to the distance of the image behind the mirror. The image is laterally inverted. This means the right side of the object appears as the left side in the image and vice versa. So you can see from this image, if the person lifts his right hand in the mirror, it shows like left hand, and it is vice versa. So that is nothing but the lateral inversion. Okay, so what are the characteristics? So first thing is the virtual means the image that cannot be obtained on screen, and second one is erect, that means upright or straight. Third one, the size of the object and the size of the image are equal, the same size as the object. The distance from the mirror to the object is same as the distance from the mirror to the image. So the laterally inverted images, that means if the person lift his right hand in the mirror, it appears as the left hand. So here one another diagram shows how the image is formed by the plane mirror. So the object O is there. When the light rays from that hits on the surface, so what happens, for our eyes it appears from it looks like it appears from inside, that is backside of the mirror. So the dotted line indicates that the mirror, so backside of the mirror, that means our eyes sees the image is coming from this point, eye point. Okay, so that image is formed there. So this is the image formation by the plane mirror. So we can tell plane mirrors create virtual upright same side images that are laterally inverted. That's why your mirror images looks like a flipped version of yourself. So what you have learned, like the light is a form of the energy that travels in a straight line, that is called a rectilinear propagation. Then light comes from the luminous object, and non-luminous objects are seen because they reflect light. So when a light hits an object, it can be absorbed, emitted, transmitted, reflected or refracted depending on the material. So the shadows form because light travels straight and can be blocked by opaque objects. Shadows have two parts, umbra and the penumbra. The pinhole camera forms inverted images using the principle of a straight line travel of the light or the rectilinear propagation of the light. So next, the important concept is reflection of the light, that is the bouncing back of the light from a smooth surface like a mirror. So the two laws of the reflection, angle of the incidence is equal to the angle of reflection. The incident ray, reflected ray and the normal lie in the same plane. And what are the key terms? Incident ray, reflected ray and normal. Incident ray means light ray striking the surface, reflected ray means a ray bouncing off, normal means perpendicular line at the point of incidence. So next, the plane mirror image characteristics. So the plane mirror forms the virtual erect laterally inverted images that are the same size as the object and appears behind the mirror at the same distance as the object. So that's it for part 1 on the basis of the light and the reflection. In the next video, we will dive into spherical mirrors, how they work, their types, and how they form images. If you found this helpful, don't forget to subscribe to the Simple Spark and hit the bell icon so you don't miss out on part 2. See you soon with the more exciting science topic. Thank you.